Today we are still in Chapter 4, however, we are throwing in Section 7.9 because it has more rules of exponents. I'm not sure why the textbook did not include this with all the other rules, but they threw it into Chapter 7 instead. So we're going to cover it now. Our objective will be to use negative exponents. But first, our warm-ups. These are pretty easy warm-ups, pretty straightforward. What does 2 to the third power mean, Kyan?
You said mean?
Yep, what does it mean?
2 times 2 times 2.
Beautiful. And what does that equal, Kyan?
8.
Thank you. So 2 to the third power means 2 times 2 times 2. We have 2 multiplied to itself 3 times. Okay, I still see a couple people every now and then, they want to say that that would equal 6, which is not the case. All right, and then 4 cubed would, of course, mean... Thank you, 4 times 4 times 4. Did anybody figure out what that would equal? Connie? What is it? Times. Jakeem? 64. Good. Okay. We are multiplying 4 to itself 3 times. 4 times 4 times 4. So the first thing that we've got is the definition of a to the negative n. So a is a non-zero real number and n is a positive integer. So n is just a negative exponent, negative n. If you have a to the negative n, that is equal to 1 over a to the positive n. So the little slogan goes, cross the line, change the sign. The line, meaning if we were to turn a to the negative n into a fraction, anything we turn into a fraction, we put it over 1. So when a to the negative n crossed that fraction line, the sign on the exponent got changed. That's the idea we're going to be working with today. We are always going to want our answers to have positive exponents. Our answers should not ever have negative exponents. So here's our first set of examples. Our goal on these is just going to be to write these with a positive exponent. A positive exponent. And then we can simplify them after that. First goal, get the exponent to be positive. So on the first example, A, if you want, you can always put these over 1 to begin with, if that helps you remember what to do next. But what we're going to do is make that cross the line. It's going to go to the denominator, and then we would change the sign on the exponent. So it becomes 10 to the positive third power when it goes down. But we can't leave the numerator blank. So what do you think we're going to put there? A 1. And that would be our almost answer. That's how we get our exponent to be positive. But then we should evaluate that also. Once your exponent is positive, then you can evaluate what that means. So it's still going to be 1 over, but what does 10 to the third power mean? 10 times 10 times 10. And we can evaluate that. What is 10 times 10 times 10? 1,000. So that would be our final answer. 1 over 1,000. All right. On letter B, we're going to start that process over. We put that over a 1, and then we have to move it so that the exponent will become positive. We need to get our exponent positive, so it needs to move. When it crosses the line, we will change the sign on the exponent. Only on the exponent. So it becomes 5 to the 4th. What's going to go in my numerator now? A 1. After we get our exponent to be a positive, we can evaluate what that means. What does 5 to the 4th power mean? 5 times 5 times 5 times 5. And then we could multiply all those 5s together. What do we get? Wonderful. So 1 over 625 would be our answer. Remember, when we have a 1 in the denominator and the bottom, it's not as important. But if you have a 1 in the numerator, you have to keep it. We can't just drop that off. Are we ready for letter C? No, not ready? Maybe ready? Some of us might be ready. Okay. On letter C, who can tell me what this would initially become? If you want, you can put that 1 underneath it. That helps you remember what to do. May? Good. 1 over 16. And you can keep the first power if you want to, now that it's a positive first power. But 16 to the first power is just 16. So our final answer would really just be 1 over 16. This next rule is my favorite rule because it's really easy to remember. If a is a non-zero real number, a to the 0 power is equal to 1. Anything to the 0 power is 1, except for 0. Okay, so if you want, you can put a little exception down here. We cannot take 0 to the 0 power. It is not possible. We can get into why later if you would like. But for now, just know that it has to be a non-zero real number. So it could be anything. Anything at all. If you're raising it to the 0 power, as long as it's not a 0, it's going to equal 1. Variables, big numbers, things in parentheses. If it's getting raised to the 0 power, it equals 1. Just a big 1, nothing else. All right, let's keep it moving. On the back, top of the back of your notes, you will see this chart. These are our other rules for exponents that we've learned so far. It's a lot of them. We've done a lot of learning lately. So let's finish off these examples that they made for us. We won't go all the way to evaluating. We'll just do kind of the first step that demonstrates that rule. So we had the product of powers, meaning we're multiplying the same base. So what do we do with the exponents? Add them. So if you want, you could make yourself a little note down here. This is when we would add exponents. So if we apply that rule to the example they gave us, we would have 2 to what power? So we're taking 3 plus what? Okay, 3 plus -5 would give me -2. Now, if you saw this problem on a quiz, a test, a homework assignment, I would want you to get rid of the negative exponent. But since we're just demonstrating these rules, we'll leave it there for now, so you can see just what the rule is. Next up, we've got quotients of powers, meaning we're dividing the same base. What did we do with the exponents then? Subtract them. So subtract the exponents. All right, so for that example, what is my base? 6, good. And we're subtracting the exponents. 3 minus 7 is -4. Again, homework, tests, quizzes, I would want positive exponents, but we'll just do the first step to show that rule. Next, we've got power of a power. You're taking a power and raising it to another exponent. What do we do with those exponents? Multiply them, times them. Multiply exponents. You're taking a power to a power, you multiply the exponents. So on their example, 2 is our base. And what would our exponent be? -6, good. All right, next we've got the power of a product. So this time we've only got one exponent, so we're not doing anything really with the exponents. It's not a add, subtract, multiply situation. That exponent is given to every factor inside. Okay, so that's not like a quick, short way to write that. The exponent is given to each factor in the parentheses. So on their example here, how many factors are in those parentheses? 2. What are they? We're on the example side. 3 and x. Okay, so we've got 3 and we've got x. And what exponent are they both getting? The -2. And if you want, you can put the times sign in between them. You don't have to. But that exponent is given to each factor. All right, power of a quotient is similar. The exponent is given to both the numerator and the denominator. So these ones, it's a little bit easier to see when there's just a single numerator, a single denominator. So our numerator 3 is getting the exponent -2. And the denominator 5 is also getting that -2. Now, on most of these, well, all of them, they came out with negative exponents. So now that we've got the initial rule, let's go through and show what the answers would become. Okay, if we were to take it another step further. If we were to take this first one another step further, we want to get rid of the negative exponent. Does anyone know what it would become? This is going to be like those first few examples we did. Keon? Yep, the top one.
2 to the second.
Not just 2 to the second. We're trying to make that power positive, but how does that happen? Natalie?
1 over 2 to the second.
Good. 1 over 2 to the second power. So we put it down in a denominator. We move it so that the exponent becomes positive. Okay, somebody else, what about that second one? 6 to the -4th. How could I rewrite it with a positive exponent? Houston? Good. 1 over 6 to the +4th power. Next one, 2 to the -6th. Jakeem? Good. 1 over 2 to the +6th power. The next one has 2 parts to it. But both of the exponents are negative, which means they both have to move. So it's still going to be 1 over. If they both had negative exponents, they're both going to go to the denominator to become positive. 3 squared and x squared would both be in the denominator. Questions about number 4? Okay. The last one, I think, is the trickiest one, because we already have a fraction that's got stuff in both the numerator and the denominator. Okay, so we know that what's in the numerator we want to move down. Cross the line, change the sign. But what about the stuff that's already in the denominator? Where do you think it's going to have to go? Natalie? Up. Okay, it's already down, can't go down, so it's got to go up. So the 3 to the negative second moves down, 5 to the negative second moves up. So 5 squared goes on top now, 3 squared goes on bottom. If you cross the line, the sign on your exponents changes. It doesn't matter which way you cross the line. So if something's negative in the denominator, the exponent will become positive if you move it up. We could go through and simplify and evaluate those even more, but we're going to move on for now. Questions about any of those? Okay, that chart can be very useful to reference if you're not sure what to do on a problem, so I would keep that handy. All right. Here are some more to simplify by applying our rules. I want you to give these a try for just a minute, get them copied down. Think about which rule you need to apply. And then if you can take it further to keep simplifying it, go ahead and do that. On A, I do want to mention, what exponent could we write on this 5 in the numerator? A 1. Okay, so if you need to write that exponent there as a reminder, go ahead and do it. If you need to rewrite this as 5 to the first divided by 5 to the negative third to see what's going on, you can do that. A fraction bar is going to mean division to us. Are we all okay with a fraction meaning division? Top divided by bottom. When we divide the same base, what do we do with the exponents? Subtract them. So we are going to take 1 minus what? Negative 3. If you subtract a negative, what are you really doing? Adding. So this becomes 5 to what power? The 4th power. We have questions about how we got to that point. The last part is just straight calculator, just 5 times 5 times 5 times 5, which we've already done today. What does it equal? 625. Do I need to put this one in a fraction? Does it need a 1 or anything? How do we know? How do we know we don't have to change it into a fraction? The exponent's not negative. After we did our subtraction step, we got a positive exponent. That means we do not need it to be under a 1. We don't have to move it anywhere. Questions about letter A? All right, on letter B, what rule do you think we need to apply? Kian? Power of a power. If we have a power of a power, what do we do to those exponents? Multiply them. So we would have b to the negative 1 times negative 3rd power. Negative 1 times negative 3 gives me a positive 3. So do I need to turn this into a fraction or move it? No, my exponent's positive now. I don't have to worry about moving it. We don't know what b is, so b cubed is as simple as it gets. Questions about letter B? All right, on letter C, we've actually got a couple different rules that we are going to have to apply. The first one being that we've got a product inside. We're multiplying a couple things inside with a power on the outside of those parentheses. We've got a product to a power. How many factors are inside those parentheses? 2. What are they? 3 and not just an x. X to the negative first power, negative 1 power. Those are my 2 factors. Each of them is getting what exponent? The 2 from the outside. Questions about the first step? Okay, next step, we can start simplifying this a little bit. 3 squared is what? 9. And then on the next part, what rule should we apply here? I think I heard someone say it softly. Power of a power. Power of a power means we do what with those exponents? Multiply. Negative 1 times 2 is negative 2. Are we done? No, why not? We got a negative exponent. So something's got to move. So anytime I see a negative exponent, if it's not already written as a fraction, I like to make it be a fraction by putting it all over 1. And then what I called this was the stay or go game. Should it stay or should it go? We think about each factor as its own thing. Should it stay or should it go? Do you think the 9 should stay where it is or go to the other side? Why should the 9 stay? The 9 is positive, and more importantly, what does it not have? A negative exponent. If I wanted to put an exponent on the number 9, what would it be? It would be a positive 1. Okay, so the 9 already has a positive exponent. It can stay. But x to the negative second power needs to go. It's got to go to the bottom. Cross that line, change the sign on your exponent. Okay, so now we don't have to put a 1 in the numerator because the 9 stayed there. So we don't have to have a placeholder. That would be our final answer. Questions about letter C? Sometimes these rules aren't so bad if we just do them one at a time, but when we start mixing them, it gets a little confusing. All right, letter D, what type of problem is it? Quotient, yes. Quotient meaning what operation are we doing? Division. Fraction bars should make you think division. So if you want to, you can rewrite it with that division sign instead of a fraction bar, but you don't have to. If we're dividing the same base, what are we doing with those exponents? Subtracting. If we divide the same base, we subtract the exponents. So negative 2 minus negative 3. Subtracting a negative means we are actually adding. So if you want, you could think about this as negative 2 plus 3. I'm not expecting that you should have to write it out separately every time. I'm just trying to show you the steps of how we're thinking through this. What is negative 2 plus 3? What is it? Which is bigger, the -2 or the 3? The 3, and the 3 is positive or negative? Positive. So our 1 is going to be positive. 5 to the first power just equals 5. So that would be our final answer on letter D. Now, technically from the very beginning on letter D, we could have handled the whole problem a little bit differently. If you like the way we just did it, that makes sense to you, that's the way you want to do it, that's fine. I'm just going to show you the other way in case you like it more. If instead, from the very beginning, I said, I don't want negative exponents. I don't want negative exponents. I want to change it so that my exponents are all positive. Where would the 5 to the -2 have gone? If I wanted that exponent to be positive. Go to the bottom. Cross the line, change the sign. If I wanted that 5 to the -3 to have a positive 3 exponent, where's it going to go? To the top. Cross the line, change the sign. Now, it's still a division problem, so I'm still going to subtract my exponents, but this time it's going to be 3 minus 2, which is still equal to 3 minus 2. Nobody knows. 1. Should hear everybody answering a question like that. 3 minus 2 equals 1, so we still end up with 5 to the first, or just 5 as our answer. What can make these problems tricky is that there are multiple ways of approaching them. Does not matter to me which way you approach it. If you prefer to do your division problem first, or if you prefer to get positive exponents first, you should get the same answer in the end. As long as you're showing me your steps and you're making valid mathematical changes one step at a time, I'll be good with it. On letter E. On this one, technically you could get rid of your negative exponent first. However, when the negative exponent's outside of parentheses, that makes it a little tricky. So I would get rid of the parentheses first, then worry about getting rid of your negative exponent. To get rid of those parentheses, I need to give that exponent to both the numerator and the denominator. So 5 gets a negative second power, and 4 gets a negative second power. Anything in those parentheses would get the power outside of it. Now, if you were following along with what we just did on letter D, the next part should hopefully be pretty straightforward. We gotta play stay or go. Should the 5 to the negative second power stay where it is, or go to the other side? Why should it go? Negative exponent means it's got to go. If it goes to the other side, the sign on the exponent will change. Should the 4 to the negative second power stay where it is or go? It also needs to go. For it to go means it's going to go where? Up to the top. In the numerator, good. And then it will also now have a positive exponent. Then the last thing to do would be to evaluate 4 squared and 5 squared. What is 4 squared? 16, and 5 squared? Beautiful. That would be our final answer. Questions about any of those steps? Okay. On letter F, again, you can go about this a couple different ways. I'm going to suggest that we go ahead and condense it to just have one base. If we're multiplying the same bases, what are we going to do with those exponents? Add them. 7 plus negative 9. -2. Okay, multiplying the same base, we add the exponents. Are we done or should we keep going? Keep on going. We do not want negative exponents, which means that it needs to move. Where's it going to go? To the denominator. When it moves to the denominator, the exponent becomes positive. But what do I need to write in my numerator this time? A 1. There wasn't anything left up there, so we have to put that 1. Last step is to evaluate 2 squared. 4. Done. Questions about letter F? Okay. On letter G. That one should already be typed out for you. That first set of parentheses, is there anything we can do to simplify inside of it? Just in this first set, anything to do inside? Does it have an exponent outside? No. So that first set of parentheses, I'm going to leave alone for that first step. The second set of parentheses, however, what do I have to do? Good. We got to multiply the exponent out here to the exponents that are already inside. What is the exponent on the x inside? A 1. The x on the inside has a positive 1 exponent right now. And we're going to take the negative 1 exponent and give it to both factors inside, both the x and the y. Okay, so when we do that, if you want, you can write it out x to the first to the negative first if you want to write it out like that. But if you already know you're taking a power to a power, what do you have to do with those exponents? Power to a power, we multiply our exponents. So 1 times negative 1 is 1 times negative 1? Negative 1. We're multiplying. 1 times negative 1 is negative 1. What about 2 times negative 1? Negative 2. Questions about that first step? Okay, next step, we are multiplying these sets of parentheses together. When we multiply the same base, what do we do with the exponents? Add them. What is the exponent on the x in the first set of parentheses? A 1. So I'm going to be taking 1 plus negative 1. What does that give me? 1 plus negative 1? 0. For the y, I've got a positive 2 plus negative 2. 2 plus negative 2 is also 0. X to the 0, y to the 0. There's that one rule that we haven't talked about since the front page. Anything to the 0 power is 1. Just a big old 1. So x to the 0 becomes 1 times y to the 0 becomes 1. 1 times 1 is 1. Final answer. Shaquem? Oh, are we ready for H? I don't sound very enthusiastic about that. Keem, what should we do first on H?
Should it be 10 to the second times n to the third parentheses?
You're on the right track. So we need to give that exponent to both factors inside. But this exponent on the outside right now is negative. So 10 to the negative second, m cubed to the negative second. Good. I just missed you saying the negative part. Okay. Let's leave 10 to the negative second alone for now so that we can finish simplifying the m part. On that m, we are taking a power to a power. So what do we do with those exponents? Multiply them. We get m to the negative 6. Good. We're just multiplying them. Okay, so 3 times negative 2 would give us negative 6. What do you think we need to do next? If we need to get rid of our negative exponents, I suggest turning that into one big fraction. And then we play our favorite game, stay or go. 10 to the negative second, should it stay or go? It should go. So 10 to the second goes to the bottom. M to the negative 6, should it stay or go? Also needs to go. So what stays in the top? A1. Very, very last step is that we could evaluate 10 squared. What is it? 100. So we have 1 over 100 times m to the 6th. Let's just see which ones we can get through. We'll at least get through I and J. They put some extras at the bottom there. We might not get to those right now. Except letter I should go pretty quick. If I wanted to get rid of those parentheses, I'm taking a power and raising it to a power. Power to a power, I need to do what with the exponents? Multiply them. 6 times 2 gives me 12. 3 times 0 gives me 0. Anything to the 0 power equals 1. So I have x to the 12th times 1. X to the 12th times 1 is just going to be x to the 12th. Easy peasy. All right, letter J has a lot going on. I still think the first thing that I want to do is get rid of those parentheses. So that -1 outside the parentheses only goes to whatever's in the parentheses. So it's going to go to that y inside and the z inside. The z on the outside is just going to stay there. It's just getting multiplied to whatever else we get. If I take a power to a power, what do I do with those exponents? Multiply them. So we've got -5 times -1. +5. Y to the 5th. We have z to the 7th to the -1st. 7 times -1 is -7. And then on the end, we still had y to the -5th. Those are all getting multiplied together. Now, if we multiply the same base, what do we do with their exponents? Multiply the same base, what do? We add the exponents. Okay, so we are going to have z to the positive or -6. Good. This z out in the front has what exponent? A 1. 1 plus -7 gives us -6. The y is going to have what exponent? A 0. 5 plus -5 is 0. Two more things we can change. First thing, we got to play stay or go. Do we want the z to the -6 to stay or go? It's got to go. Goes to the bottom, becomes a +6. The y to the 0, should it stay or go? It can stay. It doesn't have a negative exponent. But y to the 0 power equals 1. All right, we might come back to the examples K and L later. We need to write down our homework assignment. It is on page 333, 1 through 27 odd, 35 through 55 every other odd. So that means 35, 39, 43, and so on until you get to 55. Every other odd, or just the first column. Make sure you're doing the written exercises.